Hello everyone, I'll continue with the reciprocating compressors from class 1. So all of you see here, we have completed in the first video, that is work done with clearance. Now we'll calculate work done without clearance. So what is without clearance means? See here, this 12651 is the total work done. In that video we have considered the clearance and calculated the work done for whole part. Now we'll leave the clearance. So clearance, how much it is? 34563. So this I have to minus from that work done equation. So this is also following PV raised to n is equal to constant. So that same formula I will modify and write for this equation also. So without clearance, in this you can see this V1 minus V4 is free air delivery, FAD. You can write this also VA, and swept volume is V1 minus V3, that is maximum volume minus minimum volume. So that is swept volume. So after that whatever volume is remaining, this is clearance volume. This is what we have written as VC. Now we'll continue with the derivation. So this is the same diagram what I have taken. So this first see here, area 1 2, I want the work done for which area? This area 1 2 3 4 1, but I have the work done formula for what? 12651. And if I minus this area, see here I am minusing this area, minus area of 34563. If I minus that, I will get the equation. So we already derived in the first video, that is n divided by n minus 1 p1 v1 in the bracket p2 by p1 raised to n minus 1 divided by n minus 1 is the equation for the whole area, this whole area. This plus this minus this, I will do this. Same, this is also having the polytropic process. Same equation I'll write and modify the things. N divided by n minus 1 p4 v4 p3 by p4 raised to n minus 1 divided by n minus 1. This is the equation. But from this figure I can observe p3 is equal to p2 and p4 is equal to p1. So this p3 what I should write? P2, and p4 I should write p1. Same equation I write. So here you can observe, what you can observe? See here, this term n minus 1, n divided by n minus 1, and this one, this whole bracket and this whole bracket, and this term p1 term and this p1 term, all are common in this. Only change is v1 minus v4. So v1 minus v4, what it is here, you just see v1 minus v4 is free air delivery. You can substitute VA in that case. So just see in the next slide. So W is equal to n divided by n minus 1. Same thing I have taken common. P2 by P1 raised to n minus 1 by n is common. Minus 1 it is common. P1 is also common. So V1 minus V4. That V1 minus V4 here it is written as VA. So VA, how I have got free air delivery from that PV diagram. But what is PV? PV is equal to MRT. So it is P1 V1 MRT1. So P1 V1 MRT1. He has just substituted this and kept the same equation here. So this is the work done with the clearance value. Right. Now we will see some of the different efficiencies of air compressor. Isothermal efficiency. It is defined as ratio of isothermal work to the polytropic work. So isothermal work already we have derived in the first video, first derivation, that we have got as MRT1 P2 by P1, and for polytropic work we know the equation n divided by n minus 1 MRT1 P2 by P1 raised to n minus 1 divided by n minus 1. So from this MRT1 is common, so we will get this equation for isothermal efficiency. For adiabatic efficiency, it is defined as ratio of adiabatic work to the shaft work. So adiabatic work is this one. W adiabatic means gamma minus, wherever n was there I will substitute gamma, and gamma minus 1 divided by gamma minus 1 p1 v1 raised to same holds good p2 by p1 raised to n minus gamma. Here it is gamma, so here we need to change it to gamma. So gamma minus 1 by gamma minus 1 divided by bp. Bp you may calculate by the given data, that is 2 pi nt by 60. So this is the adiabatic efficiency. Now we have one more efficiency. Mechanical efficiency is defined as ratio of indicated power to the of compressor to the shaft power. So in earlier case for IC engine, what was the formula? BP by IP. Here compressor IP by BP. Why? Because they are work generating, these are work absorbing. So the formula changes, reverses. So IP you can calculate by Wn by 60 kilowatts, or one more formula is given like this, you can calculate using this. So one more efficiency is the volumetric efficiency. I will solve in the next video. It has some derivations and it is sometimes asked in the exam. So we need to derive that equation for volumetric efficiency. So things are easy. Solve, derive this one, and if you get the theory part in combination with the steam nozzle problem, you need to solve and get full 20 marks in that exam. So all of you, I hope you are following the video. Thank you.